day, students! On behalf of the teachers in Mathematics 8, I welcome you back to the second part of our lesson on rational algebraic expressions. For this week's lesson, we will perform operations on rational algebraic expressions and solve problems involving them. Adding, subtracting, multiplying, and dividing rational algebraic expressions is just like performing operations on fractions. Therefore, the rules on operations with fractions are the same rules to be applied when we add, subtract, multiply, and divide RAEs. Here is the rule when we multiply rational algebraic expressions. A over B times C over D is equal to A times C all over B times D. This means that we multiply all the numerators together and multiply all the denominators together. After doing that, we simplify the answer. Let's do that in this example. We have m squared minus 9 all over 2m plus 6 times m minus 3 all over m squared minus 6m plus 9. It is easier for us to simplify first before we multiply, and so that is what we are going to do. The numerator of the first RAE is factorable by the difference of two squares. Its factored form is the quantity m minus 3 times the quantity m plus 3. Its denominator, on the other hand, is factorable by the common monomial factoring. Its factored form is 2 times the quantity m plus 3. Let's multiply that by the factored form of the second RAE. We have the numerator m minus 3 and the factored form of the denominator, a perfect square trinomial, which is the quantity m minus 3 times the quantity m minus 3. Since the numerators and the denominators are already factored out completely, we can now divide out pairs of common factors. We have the quantity m plus 3 and the quantity m plus 3, m minus 3, and the quantity m minus 3. And lastly, the pair, the quantity m minus 3 and the quantity m minus 3. We now apply this rule. How do we do that? We multiply all the factors that remain in the numerator. We have 1 times 1 times 1. So we have 1 in the numerator. And multiply all the remaining factors in the denominator. We have 2 times 1 times 1 times 1. That would be equal to 2. The product of these two algebraic fractions is 1/2. Here are the steps when we divide rational algebraic expressions. Step 1. We copy the dividend. Step 2. We change the operation division to multiplication. Step 3. We get the reciprocal of the divisor. From C over D, we'll be having D over C. When we say reciprocal, it is actually 1 divided by the number. Or what we do is to simply interchange the terms in the numerator and the denominator. And the final step is to simplify the answer. Let's have these examples. Let's divide x squared plus 3x plus 2 all over x squared minus 4 by x over x minus 2. The numerator of our dividend is a quadratic trinomial. Its factored form is the quantity x plus 1 times the quantity x plus 2. The denominator of the dividend is a difference of two squares. Its factored form is the quantity x minus 2 times the quantity x plus 2. Here is our dividend. And then we change division to multiplication. And we get the reciprocal of our divisor. The reciprocal of x over x minus 2 is x minus 2 all over x. Now, we cancel pairs of common factors. We have the pair, the quantity x plus 2 and the quantity x plus 2. And the quantity x minus 2 over the quantity x minus 2. And finally, we multiply the remaining factors in the numerator. We have the quantity x plus 1 times 1, that is equal to x plus 1. All over, we multiply all the remaining factors in the denominator. 1 times x is equal to x. Again, I am warning you, you cannot divide out x in the numerator and x in the denominator. Why not? Because they are not factors, they are terms. Therefore, the quotient of these rational algebraic expressions is x plus 1 all over x. We follow only one rule when we add or subtract rational algebraic expressions. And that rule is to add all the numerators together or subtract all the numerators together and then copy the common denominator. Furthermore, there are two cases when adding or subtracting RAEs. The first case is when the denominators are the same, meaning to say the RAEs are similar. This example falls under case 1 since the RAEs are similar, meaning to say their denominators are the same. Let us now do the indicated operations. And so we shall be having 4x plus 2 minus the quantity 2x plus 3 plus 3x plus 1. This numerator is enclosed in parentheses since the operation before it is subtraction. Now, we copy the common denominator. The common denominator is x minus 4. Let us simplify the one that is enclosed in parentheses. How? By applying DPMA. We have here 4x plus 2 negative 1 times 2x is negative 2x. And negative 1 times 3 is negative 3. And copy the remaining terms. Plus 3x plus 1. Again, the denominator is x minus 4. We further simplify the numerator by combining similar terms. 4x, negative 2x, and 3x are similar terms. 4x minus 2x is 2x, plus 3x is 5x. The constants are also similar terms. 2 minus 3 is negative 1. Negative 1 plus 1 is 0. And then we simply copy the denominator x minus 4. Again, do not attempt to divide out the x in 5x and the x in the denominator. They are not factors, they are terms. The final answer is 5x over x minus 4. Under the second case of addition and subtraction of rational algebraic expressions, we have RAEs that are dissimilar, meaning RA is with different denominators. To get the sum of these algebraic fractions, we first need to find out what their LCD is. How do we do that? Let's do prime factorization in the first denominator. The prime factorization of 4x squared is 2 times 2 times x times x. And also do the same in the second denominator. The prime factorization for 6x cubed is 2 times 3 times x times x times x. Since we are looking for the LCM, take note that we align factors that are common. We copy and multiply all of these factors, but take common factors as 1. And so we have 2 times 2 times x times x times 3 times x. We simplify. 2 times 2 times 3 is equal to 12. And x times x times x is equal to x cubed. 12x cubed is our LCM. This means that 12x cubed is the least common denominator for our rational algebraic expressions. Since 12x cubed is the LCD for these rational algebraic expressions, we can write that as a single denominator for 7 and 4. To find the equivalent numerators for the LCD 12x cubed, what we do is to follow these steps. Divide the LCD by the original denominator. In this case, we have 12x cubed divided by 4x squared. That is equal to 3x. Multiply the resulting quotient to the original numerator. In this case, we have 3x times 7 is equal to 21x. 21x is the equivalent numerator. For the second equivalent numerator, we follow the same steps. Divide 12x cubed by 6x cubed. The resulting quotient is 2. Multiply the resulting quotient 2 to the original numerator. 2 times 4 is equal to 8. 8 is the other equivalent numerator. And then we finalize our answer. Are 21x and 8 similar terms? No. Since we can no longer combine 21x and 8, and there is no other factor common to both the numerator and the denominator aside from 1, 21x plus 8 all over 12x cubed is the sum of these rational algebraic expressions. Congratulations, learners! Another set of treasures has been added to your learning box. See you again next time for another set of lessons. It is easier for us. Its factored form is the quantity m minus or what we do is to simply is to simply interchange the new. Therefore, the quotient in this scenario, tama ba ako? The quotient of these algebraic fractions is. And that same denominator in that case is x minus 4. Okay na ba yun? Okay. So let's add and subtract them. May kulang? Let's perform the indicated operations of adding and subtraction. I hope nakita nyo na inalign ko. Since we are looking for the divide the LCD by the original. Divide the LCD by the. Therefore, we cannot combine them. Since 21x and 8 are not
similar. We cannot combine.
Since we can no longer combine. Okay? See you again next time for another. See you again next time for another set of lessons.